So we're going to talk about how we can multiply when indices are involved. So a good example of this would be a to the power of 2 times a to the power of 3. Okay, so the way I'm going to explain this is actually by doing the expanded form of these. So a to the power of 2 becomes a times a, and then obviously we have our times, and then we have a to the power of 3. So a times a times a. Okay, so a squared times a to the power of 3 can be expanded to a times a times a times a times a. All right, now when we look at this, it suddenly becomes really clear that this is a to the power of 5, because we have a multiplied by itself 5 times. All right, a to the power of 5. The thing that you're going to notice is that 2 plus 3 makes 5. And you'll find that this actually works for all of these situations. Okay, so the rule that we have, so our rule, all right, is a to the power of something times a to the power of something else. I'm going to use n and m to represent something and something else, is the same as a to the power of those two powers added together. Okay, now I'm going to do this next part in red because you don't have to write it, but you can find that this is actually true for any rule you try. So if I have b to the power of 3 times b to the power of 4, and I write it out, b times b times b, and then I do my other 4, so times b, and I'll fit a little times b there. All right, and then when I count them out, it comes out to be b to the power of 7. Okay, so this is how we can multiply. The thing to note here is that the bases have to be the same. Okay, so we have to have a, and the base doesn't change. Okay, so when we do it with a real life example, so if I have 3 to the power of 2 times 3 to the power of 3, my answer is still going to be 3 to the power of 5. Okay, I don't do 9 to the power of 5. I don't do 3 times 3. I keep the base the same and just add the powers.